Green's green. All right, things are working right now. Good, good. Okay, let me put this stuff on so I can be proper, not get in trouble. Okay.
Don't be jealous. Don't be jealous. Yeah, don't be jealous. You know what? I think I can do the jealous person thing. I'm not jealous.
Watch your feet, Adam. Okay. Watch your feet on that stand. Okay.
Right there.
That's fine. Thank you. Okay. Okay, I don't know what page. I know where I'm. I know where I'm at. I don't know what page. We're on page what? 1 still?
Yeah, we're still on 1.
Okay, and this was the last thing I think we talked about.
Light.
That light cannot travel through objects.
We did that already. Yeah.
Isn't that what I just said?
Yes.
This is the last thing we talked about,
Yes, sir.
which means we've already talked about it. Okay? Okay? Get that through your head, please. Okay?
Yes, sir.
Okay?
I'll consider it.
Okay. It cannot be heard. Okay? Just like that. You saw the light, you didn't hear it. You saw it. Okay? Light cannot travel around corners. Why? Because light travels in a straight line, not a curve. And to go around the corner, Gavin, it has to go in a curve. Okay? Unless you're Mr. Hulk and you go through the wall, then light can follow. But since you're not Mr. Hulk,
I'm Hulk.
okay? Okay, moving on. Where's my clicker? Here it is. Shh. Tony, no flirting.
What?
Here's what light can do.
Travel faster than sound.
Okay, here's what light can do. It can travel faster than sound. So by the time you say your next word, which you don't, light has already traveled. The speed faster than me? No, but the speed of light is 186,000 miles per second. Okay, that's how I get over here so quickly every day. Okay,
Yeah, right, Mr. Brown.
don't laugh. Don't laugh. Okay, whenever you see me, there's just this. Today that there's this maroon and black stripe behind me. Okay, yeah. Okay. Okay, right now, Ariel, Shane,
God.
Tony, Shane has a question. Okay, which question?
You know how they find out how many miles an hour that is?
They send a beam of light, and however long it takes to get to that object to shine it. Okay, and then they do some calculations based upon the distance. Okay, and how much time. Okay, the speed of light again is 186,000 miles per second. What?
Sorry, I had a question about
What?
going through around the corners.
Uh-huh.
You know, like when you said light can't travel through objects, but you can see it around the cracks.
Uh-huh.
Is that going?
No, that's basically the reflection of light that you're seeing.
So it's an effect of light, not the actual light.
Right. Okay, light can go to the moon and back in 3 seconds. Uno, dos, tres. It's back. Okay? Okay?
1, 2, 3.
I have a question.
What?
I could run faster than 186, 000. I could run
186,000.
Yes, I can run 2,160,000 miles per hour.
Uh-huh.
That sounds something like a 5-year-old.
Yeah. Okay.
250,000
Now,
UC.
shh. Look at this chart.
I can
Gives you just some illustrations. Shh. Quiet. Earth to the moon, 1.3 light seconds. Earth to the sun, 8 light minutes. So now we've gone from seconds to minutes to the sun. Okay? Earth to Mars, 12.7 light minutes. Earth to Alpha Centauri, that's a big galaxy out there, 4.4 light years. Earth to far side of Milky Way galaxy, which is what we are part of. Okay? It goes at 52,000 light years. So light travels faster than actual speed. Okay? So it just gives you the idea. If you ever try to match this, okay, you're going to find yourself in one dizzy spin. But just passing through. Transparent materials, or what we call transparent, that allows light to pass straight through. Okay? Uh-huh.
Can you go backward? I just want to see if it's spelled right. Spelled wrong.
Ready? Yes, sir. Oh. Okay. Allowing light to pass through, that's what we call transparent. So, a person standing on one side of a transparent object can view things on the other side. That's being transparent, like a window. Okay? Like an hourglass. You see the object inside. Glasses. Okay, you can look through the glass. That's being transparent. A drinking glass. You can see what's inside of it. A magnifying glass. Okay? So you've got three different things here. Well, that's what we're going to be talking about. The comparisons of the three. Transparent, being able to see through it. The translucent is the next one, which means that partial visual, okay? Which means that object, that window or whatever, is blocking some of the rays. And then opaque means you can't see through it. Like the wall, it's opaque, okay? The sun's rays come in through a window. That's being transparent. So if you hear this word on TV all the time, I just wish that they would be transparent about their whatever. You hear this in the election all the time. The Democrats want the Republicans to be transparent in their dealings. The Republicans want the Democrats to be transparent, which just means being able to see what's actually going on. Okay? Kind of a figure of speech, but it still plays on these ideas, being able to see what is being talked about. Okay, opaque materials, or OPAQUE, opaque, are materials that does not let light pass through it. Okay, now I'm kind of taking these out of order a little bit, but you cannot shine a light through a wall. Okay? That's an opaque situation. Okay? It's not allowing the light to shine through. So in this illustration, he's trying to shine light through this wood. Well, the wood is so dense and coarse that it will not let it shine through. Now obviously the thinner you get with the wood, the less opaque it gets. And there is some wood that would allow some light, okay, not transparent light, but it would allow some light, so it would be the translucent light to pass through. I have a feeling that's my family, but hang on, let me just double check. Yep. Okay, so the third one is translucent. Diffuses or it scatters the light. Okay? So you see this picture of the guy on one side of the window has a translucent type glass. Okay? Light's going to shine through, or the reflections of light's going to shine through. Not the actual beam of light, but when it hits the window, it's going to the glare of it's going to shine through. And a lot of times they put these on front doors, okay, to where people can't see actually what's going on inside, or it may not be as clear. They put these on bathroom windows a lot of times, okay, especially the higher ones, so that light can still shine in, but you can't see in as well, okay. So these are translucent objects. So again, we got the three pictures, the comparisons. Transparent, you can see through it. Translucent, you can kind of see through it. The light's shining through it, but not full strength like it would the transparent. And then you got the opaque, where light cannot pass through it at all. Translucent. We showed you the illustration the other day about this, that light doesn't go through your body, but the reflections of the light do. Okay? And so, in this situation, you can see the light through the fingers, or the remnants of the light, the reflections of the light. Okay? You got a cloudy day, and it's during the day, so you know the sun's shining, but it's kind of a dull look down here on Earth because of the clouds. Okay? But yet the sun is still shining, so you still get the glow of the sun, the light, but you don't have the direct rays, the transparent aspect. You have a translucent idea. Okay? A shadow gets created because of the light. This is a spot of darkness cast by an opaque or a dark object. Okay? You have the one up on the top left, a bunch of people. The spotlight is on the other side. And as it's shining there, it's showing its shadow. People always like, when you have a bright light and you're shining on an object, people always like to do finger shadows. Okay? Like it is on the bottom. You kind of see with the one that's a cat. Okay, right there. Yes, sir.
Oh, that picture on the right was actually taken from the moon?
No. Okay, now, the one on the right. That is actually a man on the moon. Okay, when they landed on the moon and they walked on the moon, the shadow isn't coming from the guy standing there. The shadow is coming from the guy that's taking the picture. Okay? So the guy taking the picture is standing down here someplace. The sun is shining on the moon. Okay? So the sun is creating the shadow of the man taking the picture. This is part of the spacecraft that landed on the moon. The shadow of it. Okay? So shadows are just a spot of darkness cast by the opaque or the dark object. Yes, sir.
One more question. The sun, it's so hot that it can burn stuff up. Wouldn't it burn up part of the moon?
No, because it's far enough away. Okay, it's not right next to it. Even though sometimes, from our perspective, it looks like it's really close. It's very far away.
Like super
Okay.
far, super
No,
far.
super far. Yeah.
Oh, yeah.
Landed.
That one on the moon. like the moon's supposed to be bright?
Half of it. The other half is dark because the moon doesn't rotate. The moon stays with us as we rotate, but the moon stays as it's going around. It stays like this, and if the sun's over here, it's going to kind of follow the sun, whereas we are spinning on our axis as we go around the sun. Okay, I had that illustration. Sun's over here and the moon's going like this, but it's staying as we're spinning this. The moon is staying still. Okay, and so we only see half the moon at all times. The other side is dark. Okay, yes sir.
So you know how, like, there's a flag right there?
Uh-huh.
Do they, like, put that on for, like, their state so, like, people know that they've been up there?
They put a flag. They have put a flag up on the moon's surface for every landing that the United States has been up, and the United States is the only nation that's been on the moon. Okay, so I think we have, like, don't quote me on this right offhand, because I'm thinking that we have like 11 to 13, or maybe it's just 8, someplace in that area, of flags up there for every time that they've landed on the moon. They put it up. Now look at, if you can kind of see, that flag is not really waving. I know it's a still picture, but even in still pictures you can tell if something's waving or moving. It's not. It is there, and why? Why is the flag just sticking out? Tony?
Because there's, like, gravity?
No. Not on the moon. Shane?
There's zero gravity?
Zero gravity. Yes. There's no air. Okay? There's no air like here on Earth. And the air that's here, you know, they got the wind, so it's going to blow everything. It blows our flag all the time. Okay? It's constantly in movement. Okay? But on the moon, it's not, so it's just going to stick straight out all the time. Okay? Gavin?
Is there, like, straight zero gravity on the moon, or is it, like,
There's zero gravity because those space, the astronauts have gravity suits that allows them to walk on the moon. Otherwise, they just float off, basically. Okay, need to move on. What?
Do the flag stay on the moon?
Can you stay on the moon? No. Well, for a short period of time, but, you know, you're not going to stay up there to live. No. Okay. A shadow is the same shape as the object that it comes from. Okay? Now, I want you to look at these pictures. The one on the left is from a bicycle. Okay? The one in the middle is from two ladies. But what does the shadow represent? A dog. Okay? So it's just how they are positioned shows the dog of a shadow. Okay? And then the fence, the kind of fence that it is, shows a piano keyboard.
Where's the one that shows
Okay.
the dog?
The middle one.
Oh yeah, I see that.
Look it. It's E.T. phone home the first one. You see it?
That probably is it. I didn't realize that,
like it.
but yeah, it probably is.
E.T.
Okay?
On the right?
Yeah.
You see it?
It's a movie.
The size of the shadow varies with the position of the sun. Okay?
Harry.
So here the steps are going up to the right. Okay? But the shadow is coming down to the bottom right and then out back towards the camera. Okay? Because of the angle of the space that the sun is shining through. Okay? So, it's going to change based upon its variation. Three 3.1. You have probably 10 minutes to work on it. Okay? 3.1. Okay? Gianni, Make sure you're getting things done for me, okay? 3.1 is tonight's homework. So the class has time right now, so work on it, get it done, turn it in, okay? And we'll get it going, okay? Have a great weekend, Gianni, and we'll see you on Monday.